external resistance will be then that 3.333 plus that 8 there, that's in series, so plus the 8, and you get 11.33 ohms. Okay. So now, because there's internal resistance, we're going to look at the new formula. We look at that formula, E is I times R plus R. Okay, remember the current is the same everywhere. The EMF, they told us, is 20. We want to get the current. The external resistance is 11.33. And the internal resistance, they tell us, is 1. Okay, so if we calculate that current there, we get it's not that bad, Zanelli, huh? Why are you complaining?
No, it's just too hot.
Really? Hot? I'm getting cold. Yes, please. So you get 1.62 ohms. All right. Not ohms, thank you. What's wrong? What did you get? Did you add these two together? And then you must say 20 divided by that. Okay. All right. So now that we have the current, now they ask, what is the potential difference, the volts, that goes to the 5 ohms? Okay, right. Now we know that the volts in parallel is the same. Okay, now you can see it counts 4 marks. 4 marks here normally means either 2 very small calculations, or it means an idea, a concept that you must know, and a calculation. Okay, so with this, you'll always see there's about 7 options of how you could have answered. In my head, I say either I can do, if I want to get what's the volts that goes there, I can calculate what is the volts that is taken there and subtract it from 20 to get that volts. Or I can say I know what the resistance of them are together. I've just calculated it, right? There, 3.33. And I know what is the current that will split up, but what is the total current together? I've calculated that as well just now. So what I can do is I can say I know the resistance, I know the current, so I can get the volts that is here, because it will be the same volts in here as in there. Okay, so I'm going to choose the second option, but you can also do the first option. It doesn't matter. So what I'm going to say, 8.2.2. So I'm going to say in the parallel circuit that I'm going to look at, I know R parallel I've calculated to be 3.33. I know the current that will split up, but the current together there will be 1.62. So now I just need the volts. So volts is current times resistance, 1.62 times 3.33. And you should get 5.40 volts. Okay, so you can see 4 marks there. The 1 mark, the idea was that you should be able to know that the current there is the same, not the same for both. It's the same as the total current together, the 2 parallel. Okay, then they ask at question 8.2.3, calculate the total power supplied by the battery, 3 marks. So we will need the power, they ask. We know the current that goes through the battery is the total current. That is 1.62. Okay, what is the volts of the battery? 20. So it's formula, substitute, answer. So if we look at the formula there, I think that's the formula. What's wrong? It is. Yes, yes. Because EMF is volts. The maximum volts possible. I just want to double check something quickly. What question is this? Yeah. All right. So we have, 20 times 1.62, and you should get 32.4 watts. What's wrong? Okay. If we look at the next question. Okay. The next question is a good theory idea question. Okay, they say that you have two graphs that shows the relationship between current and potential difference of two conductors. Then they give it to you, you have current and you have potential difference. Then you can see the one is a straight line and the other one is curvy. Okay, now this is the grade 11 knowledge that you should have. If you see a straight line, it means what? Obeys Ohm's law. It means the temperature remains constant. It means the resistance is constant. Okay, so if you see that, you know Ohm's law is sharp, constant, resistance, and temperature. Okay, where you know if it means a curve, it does not obey Ohm's law. Okay. Now the ask there, 9.1.1, state Ohm's law in words. You should know that it's the potential difference across the conductor is directly proportional to the current in the conductor, provided that the temperature remains constant. Okay, then ask which one of the two conductors is ohmic, meaning which one obeys Ohm's law. Ohmic means obeys Ohm's law. We're going to say that is X. Why is it X? Because it is a straight line. Okay? So, what did we look at here? We made a graphical conclusion. We said it looks like a straight line. Straight line graph. And we can say from a straight line, it means the y-axis is directly proportional to the x-axis. And in this one specifically, the current is directly proportional to the volts. Okay, so you guys know all of this stuff. You saw that if it's a straight line, that is what it means. Okay, so don't make it too complex. Then, the next one looks difficult, but it really, really isn't. Okay, so they say in the diagram below, a battery with an EMF of 6 volts and an internal resistance of 2 ohms is connected with 3 resistors, blah, 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 blah. Are you done? Okay. Right. Now they ask you there, calculate the reading on the ammeter. So what do we do before this? We consider the circuit. We say, all right, our little man walks, do. They get here, they split up. What happens here? They get together. The total current passes through that ammeter. So I'll write for myself, the total current passes through it. Then the total current passes there, total current. And the total current have to pass through there, so that is the total current. Sharp. So what did they ask? What is the reading on the ammeter? They're basically asking you calculate the total current in the circuit. Okay, so that is what we are going to do. I'm just going to go to the next. Near. Next page. So they ask us to calculate at question 9.2.1, calculate the total current. So for that I need the total resistance. And when I write it like that now for myself from now on, total resistance means the external total resistance. Okay, we have the internal resistance is 2. We have the EMF is 6. Okay, the total external resistance is difficult. Why? Because there's a parallel branch. So we must first calculate that parallel. That's 1 over R. Parallel is 1 over 10 plus 1 over 15. 5 over 30. I think. So R parallel is 30 over 5. That gives me 6. Am I on the right path with that 6? I think so, because it's smaller than 10. So my R total external is the 6 plus, I'm just going to page back. So it's those two together are 6. And we must plus that 10 with it. So we're going to add 10, and that is 16 ohms. So now I know that is 16. Then I go to my formula. The EMF is current plus resistance plus resistance. I want the current. The EMF is 6. That's 16 plus 2. And you get the current to be, I think, 0.333333 amperes. Okay, now this is the most important question, and then we will, second most important question. They say now, you open the switch, okay? They say you open that switch. What does that switch do? It eliminates this whole branch. So how does our circuit change? It now becomes a series circuit. Okay? So now, so that's what happens. And the question that they ask there is, how will the ammeter reading change? How will the total current change? And it only counts 2 marks. Okay, so our question to ourselves is, when we open the switch, what is the big thing that changed? The big thing that changed is the total resistance increased. That's a big thing that changed. What is the effect of that big thing? What effect would it have? Well, we know that current is inversely proportional to resistance. So if the total resistance increases, then the total current decreases. So what will happen to that ammeter reading? It will decrease. Okay. You're all with me there? Then the most important question. That was second most. This is the most important. They ask, how will the voltmeter reading compare? Okay, now, the voltmeter reading is over the cells. And what did we say the voltmeter reading over the cells? What does that measure? The volts external. The volts that is available for the rest of the circuit. Okay, we did this question yesterday, ne? Here we said the whole story of voltmeter external, blah, 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 blah. Right, so it's the same question. They love to ask this question. They always ask this question. Okay, so how will that volts external change? Increase, decrease, and remains the same. Give a reason for your answer. So if you get to that volts external question, you go write for yourself this formula. And you multiply in the current, and you say that's volts external plus volts internal. Okay, so their question is, what will happen with volts external? We have already discussed, mentioned, said that the total resistance increased, meaning the total current decreased. We said that in the previous question. Okay, right. So we can, just for completion's sake, just repeat that. Say the total resistance increased. That means the total current decreased. What remains the same? EMF and the internal resistance remains constant. Those two things did not change. You didn't add another battery. Or you didn't remove a battery. So the EMF and the internal resistance remains constant. Okay, now we want to look at the effect. Okay, so I want you to please look up here. So that remains constant. That remains constant. But the current decreased. So what happened to the internal volts? It decreased. Okay, so this is constant. This one decreased. What will happen to volts external? It will increase. Okay, so we're going to say we have to mention that volts internal decreases. Do you have to mention that? You get a mark for that. That means the volts external or the voltmeter reading increases. Okay, so please